Let's start talking about multiplication and division by 6. So let me remind you of certain facts that are really important, and it never hurts to remind ourselves of those facts. So the first thing is, this is really important, multiplication is just notation, right? So this is something that I've said again and again. Multiplication is merely notation. It's not a new idea, it's just the same idea that we had. So, what do we mean? So, what I mean is that if we have, so here we have, as you can see, and the book, as usual, points out in a slightly different way, this is 1 4, 2 fours, 3 fours, 4 fours, 5 fours, and 6 fours. So we know that if I have 6 fours, 1, 2, 3, 4, 5, so I have 5 and I have 6 fours, this is very long, so I will denote it by, so this is just, this equality is the notation, and I will denote it by 6 fours. So here's 6 fours, and I do not say the multiplication symbol, and I just say it's 6 fours. So here you have 6 fours. And the answer is equal to, that's a calculation. And the way we calculate it is we add the 4 6 times to get the answer 24, and then we can memorize it. And that's very important, that we need to memorize that 6 fours are 24. We don't want to recalculate all the time. That's an important part, okay? Now, this is the first part. So you can see this is what the book is trying to get across in this portion, okay? Now, in the next portion, there's a very important part which the book is talking about, and this part is the commutative law. So the commutative law is really interesting. What it says is that 5 sixes is going to be equal to 6 fives. It doesn't matter what the answer is. So this is the commutative law. So this is the commutative law. So of multiplication. So the question is, why is it true? I don't even know what 5 sixes are. It doesn't matter what it is, but it has to be equal to 6 fives. So this equality is different, and this equality is saying has to be. So this is saying it's not notation, it is saying has to be equal to 6 into 5. Why is that? So let's look at 6 fives. So here we have, so now first look for 5 sixes. So here's a 6, here's a 6, 2 sixes, 3 sixes, 4 sixes, and 5 sixes. I'm just counting the squares. So when I count horizontally, I get 5 sixes. But if I take the same picture and start counting vertically, so I have a 5, 1 5, 2 fives, 3 fives, 4 fives, 5 fives, and 6 fives. So since I'm counting the same number of squares, 5 sixes has to be equal to 6 fives. So this shows you in general that if you have really large numbers, like maybe 479 multiplied by 806, this is equal to 806 multiplied by 479. I actually don't know what 479 multiplied by 806 is, but whatever it is, it has to be equal to the 806 multiplied by 479 because of the commutative law. Okay, that's an important thing that we learn. Now let's look at the third part. So the third part actually is talking about another very important law, which is called the distributive law. So let's see what the distributive law is. So it looks very straightforward. So let's say I want to count 6 sixes, okay? So let's first count the 6 sixes in a very simple way. So here's 1 6, 2 sixes, 3 sixes, 4 sixes, and 5 sixes. So I just counted 5 sixes. And then I'm going to add on the sixth 6 right over here. So these are 6 sixes. So that means, please note, that if 5 sixes are going to be equal to 30, then this would mean that 6 sixes must be equal to 30 plus 6. You're just adding a 6, right? Because 5 sixes was already 30, and you just added a row of 6s, so it ought to be equal to 36, right? Now this may seem very simple, so let's move on to the next page and look at this. So let's say we want to figure out what this is. So let's say I'm counting 6s again. So here's I'm counting 6s, 1 6, 1 6, 2 6s, 3 6s, 4 6s, 5 6s. I have 5 6s. Then I'm going to add 2 more. So this is a 6 6 and this is a 7 6. So now please note again that if 5 6s is going to be equal to 30, then this would clearly imply that 7 6s would just be equal to the old 30 plus 12, right? Because there are 2 6s downstairs and 2 6s are 12, right? So this is just 2 6s, right? And 30 plus 12 is equal to 42. So what it means is, and we can do the same thing. So let's do one more thing over here. So let's say I'm trying to do 8 6s. So if I'm trying to think about 8 6s, I'm trying to calculate what 8 6s are, but 8 6s can be computed. I can first compute the 4 6s, and you can see I already know that 4 6s are 24. So this is 1 6, 2 6s, 3 6s, 4 6s. And if I've counted correctly, this would be equal to 24. So if I know 4 6s are 24. So now please note that I can take my 8 6s and break them up into another 4 6s as well, right? So these are 4 6s and these are 4 6s over here, right? For a total of 8 6s. So if the first 8 6s, 4 6s give me 24, then the second 4 6s will also give me 24, and 8 6s must be equal to 24 plus 24, which should be equal to 48, okay? Or in other words, this should be equal to 2 24s, right? So, which is equal to 48. So what I want to emphasize really is that this picture is beautiful, but it's really talking about a very important law, which is called the distributive law. So this is called the distributive law. It's very simple, and these pictures really act as a proof of the distributive law. So this is the distributive law.